Hi students, welcome to Vari Medical Academy. So, உங்களுக்கு எல்லாத்துக்கும் ஒரு குட் நியூஸ். வாரி மெடிக்கல் அகாடமி சார்பாக இனிவரும் நாட்கள் டெய்லியும் ஒவ்வொரு டாபிக் நம்மளுடைய ஃபேக்கல்டி மெம்பர்ஸ் லைவ் வீடியோ ஸ்ட்ரீம் உங்களுக்கு கொடுக்க போறாங்க. Wish you all the best my dear future doctors. டாபிக் ஏதாவது வந்து கிளாரிட்டி வேணும் அப்படிங்கிற எந்த கண்டென்ட் ஆனாலும் கமெண்ட்ல தெரியப்படுத்துங்க. அதுக்குண்டான சொல்யூஷன் வாரி மெடிக்கல் அகாடமி சார்பாக கொடுக்க ரெடியா இருக்கும். இந்த மாதிரி வீடியோக்கள் உங்களுக்கு பிடிச்சிருந்தா மறக்காம லைக் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணிக்கோங்க.
Good morning students. In last class I explained chemical bonding based on stability of atoms, ionic bond, and next lattice energy and Lewis dot structures. How to write the Lewis dot structures I explained videos number 1 and 2. But how to prepare the NEET exam? NEET exam because many lakhs of people are preparing for NEET exam, and how to get the good marks in chemistry. First of all, there is three parts are there. One is the inorganic chemistry, and next one is organic chemistry. Next one is physical chemistry. Another one is the physical chemistry. Total 50 questions are given. From 50 questions, you have to attempt only 45 questions. 5 questions is the choice. From coming to the inorganic chemistry, we are focused S block elements, and next one is a P block elements, and next D and F block elements, and coordination chemistry. For these chapters, you have to focus only NCERT book. NCERT is 100%. It is useful NCERT. The last time S block elements, this one concept, beryllium chloride. Beryllium chloride is a covalent halide. It forms covalent halide. It is soluble in organic solvents. That's why read only S block elements from NCERT. Even P block elements, what are the P block elements? That is 13th, 14th, 15th, 16th and 17th. These are the P block elements. What are the especially the particular reactions and reactivity orders? What is the reactivity means? So for example, this reactivity water, it reacts with halogens and solubilities. And next one is the dipole moment. Like that orders that they are asking in S block and P block. And D and F block elements, they are asking magnetic properties and color properties of the complexes. And if you score more means in inorganic chemistry, line by line from NCERT book. How to read the NCERT book is also one of the difficult task. But you have to concentrate every point on NCERT book. Now coming from this, in inorganic chemistry, maximum 13 to 14 questions are coming every year. Now coming to the organic chemistry. Now organic chemistry important topics are GOC, general organic chemistry, and next one is the hydrocarbons. The last time 4 questions are given from GOC 2021 exam, and hydrocarbons 2 questions are given. And next one is the carbonyl compounds. Carbonyl compounds means aldehydes and ketones. And next one is the very important biomolecules. Structures, what is the bond, what is the linkage is present between two glucose, maltose, sucrose, like that question they are asking. In this total organic chemistry, they are asking a preparation methods, and next very important is named reactions. Next one is another very important reagents. What are the oxidizing and reducing reagents? From this one, you have to more concentrate on GOC. They are asking carbocation, carbanion, free radicals, and next one is inductive effect, mesomeric effect, electromeric effect, hyperconjugation. Next, another very important is separation techniques. You have to more concentrate on stability of carbocation, carbanion, free radicals. From hydrocarbons, you have to concentrate on ozonolysis. In carbonyl compounds and aldol condensation and crossed aldol reaction, Cannizzaro reaction, next non-azole reaction, HCV-Z reaction, and biomolecules also maximum it is present in biology and chemistry. You have to read in NCERT book. And every time there are questions are 12 to 13 from organic chemistry. And very important topic is physical chemistry. And many of the NEET aspirants are drawback is physical chemistry. Actually, in physical chemistry, in the first year chemistry, atomic structure. Another one is the states of matter. Next one, equilibrium. Next one is thermodynamics. From this units, minimum there is a two questions. Minimum 7 to 8 questions are coming from these units: atomic structure, states of matter, equilibrium, and thermodynamics. From atomic structure, where you concentrate, they concentrate on atomic structure, mass number of protons, number of neutrons. Next one is we can take a spectrum of hydrogen spectrum, Lyman series, Balmer series. The formulas are very important. And from atomic structure, the quantum numbers also very important. And you can concentrate last time lambda equal to E equal to hc by lambda, nu equal to lambda equal to c by lambda. Now lambda equal to c by nu. This is the given last time. That's why basics very important from atomic structure. How to read the states of matter? Now states of matter, the gaseous laws. What are the gaseous laws? Boyle's law, Charles' law, Avogadro's law, Dalton's law of partial pressure. Very important is Dalton's law of partial pressure. Everyone question asking zone in states of matter. Next one is the positive deviation and negative deviation from compressibility factor. What is the compressibility factor? Z is equal to PV by RT. And Van der Waals gas equations. Also very important. From equilibrium, it's coming two questions, and Kp and Kc. Kc is equal to RT power delta Ng. And salt hydrolysis, what they are concentrate last time? Salt hydrolysis is very important. And Ostwald's dilution principle, this is also they are taking last time. And thermodynamics means very easy, maximum numericals they are given, but in 18, 19, 20 and 21 from thermodynamics there are very easy relations they are asking. For example, delta W is equal to minus PdV. This one formula based on this one they are asking questions. And next one is the spontaneous delta G is equal to H minus T delta S. Delta G is equal to delta H minus T delta S. So what is spontaneity? Spontaneity means it's the process which occur by its own or proper initiation. That is called spontaneous process. All natural reactions are the spontaneous. All natural reaction, water flow from high hills to lower hills, that is also spontaneous reaction. There is no external agent is required. That is called spontaneous. But who will explain the spontaneity? delta G is equal to delta H minus T delta S. But entropy is not explained and enthalpy also not explained. What is enthalpy? Total heat content of the system. Means if exothermic reaction means heat released, endothermic reaction means heat absorbed. Next, coming to the entropy. Entropy means in the universe, entropy is maximum disorderness of the system, randomness of the system increases, entropy increases. The final equation is this one. And these are the thermodynamics, equilibrium, states of matter, atomic structure. And second year chemistry, solid state, electrochemistry, surface chemistry, chemical kinetics. These also very important. The maximum questions are coming from physical chemistry, that is the 18 to 20 questions. That's why how to concentrate inorganic and organic chemistry from NCERT, and physical chemistry you have to do the numericals. Okay, I will start a chemical bonding. Already 1 and 2 I explained Lewis dot structures. Another one is the ionic bond explained. Now today we have to explain percentage of covalent character in ionic bond. This is the percentage of covalent character in ionic bond. This one is proposed by Fazan's rule. Fazan's is the scientist. Fazan's rule. What is Fazan's rule? Means percentage of covalent character he is explained. Means there is no 100% ionic bond. Means 100% not ionic character is present. No 100% ionic character. The ionic bond means not 100% is present. Now some percentage of covalent character is present. This is explained by Fazan's rule. How he is explaining? Because he is taking a small, now I am taking cation, this one is a cation, I am taking anion. Anion is a somewhat big size, anion means negative charges are present. Now the cation is attracting the anion. When cation is attracting the nearby anion means that this one is distorted. The shape is distorted. Distorted means one side is more negative charge. Here is a more negative charge. Here is a less negative charge. This distortion occur in anion, that is called polarizability. Distortion or polarization in anion, that is called polarizability. When presence of cation, in the presence of cation, this cation is attracting this distortion, unequal distortion, and this polarization of anion, the responsible of cation is called as polarizing power of cation. If more polarizing power of cation means more distortion is occur. That distortion is called as polarizability of anion. Now what are the factors? One is the small size of cation. When small size of cation, what happened? If small size of cation means polarizing power increases. When polarizing power increases means covalent character increases. First point is the small size of the cation. Next one is the more charge on cation. More charge on cation. Now more charge means polarizing power increases. Now covalent character increases. Next one is a pseudo noble gas configuration. Pseudo noble gas configuration. What are the important points about cation? Cation is small size of the cation, polarizing power increases, covalent character increases. Next, more charge on the cation, polarizing power increases, covalent character increases. And pseudo noble gas means there is no pseudo means false. Noble gas configuration. What is a noble gas configuration? NS2, NP6, N-1, D10. ND10 we can write NS2, NP6, ND10. This is the pseudo noble gas configuration that cations are more polarizing power. What are the example? I am taking copper plus, silver plus and Rm plus. That is Rm plus. Now these pseudo noble gas configuration means more polarizing power. Now I am taking example. What is the example? First one is the small size of the cation. Now I am taking lithium, sodium, potassium, rubidium and cesium plus. Cesium plus, K plus, Na plus, lithium plus. Now lithium to cesium, the atomic size is increases because the number of shells are increases. Number of shells are increases means atomic size is increases. And which one is more polarizing power? Lithium is more polarizing power because of small size. Small size of the cation, more distortion of the anion. That's why lithium is the more polarizing power. If you take lithium chloride, sodium chloride and lithium, sodium and potassium chloride, which one is a more covalent character? Covalent character means polarizing power increases, covalent character increases. That's why lithium is more covalent character, sodium chloride and potassium chloride. Now I am coming to the lithium plus and Na plus. We can take beryllium plus 2. Next one is lithium, beryllium, aluminium plus 3. Which one is the more covalent character, more polarizing power? Already I told, cation, small size of the cation, polarizing power increases, covalent character increases. Now lithium is a charge. Charge means plus 1, plus 2, plus 3. Charge increases means covalent character increases. Next one is the pseudo noble gas configuration, copper plus. This one is the size according to the charge on the cation. When charges means like this order, if you take sizes means like this order, lithium, sodium, potassium chloride. If you take pseudo noble gas configuration means copper. Copper I am taking, what is the electronic configuration? 3d10, 4s1. If you take copper plus means that is the, if you, this one is cancel, plus means this one cancel. Now what is the electronic configuration? NS2, NP6, ND10. This one is the pseudo noble gas configuration having cations are more polarizing power, more covalent character. Simple. Distortion or polarization of anion, that is called polarizability. Polarizing power of cation, polarizability of anion. If small size of cation means it can be distort anion more. That's why small size of cation, more polarizing power, more covalent character. Coming to the anion. What are the important points about anion? Anion means negatively charged an ion Anion means here is a larger size. Larger size. When size is increases means polarizability. Polarizability increases. When polarizability increases means covalent character increases. Next, coming to the charge. More charge on the anion. If anion having more charge means again polarizability increases. Now covalent character increases. These are the important points about anion. If you take anion F minus SO4 2 minus, if you take PO4 3 minus, which one is a more polarizing power? Not polarizing power, polarizability. Which one is the more polarizability? More charge on the anion. That's why. And fluorine, sulfur and phosphorus, phosphate PO4 3 minus, sulfate SO4 2 minus, F minus. Now coming to these are the important points about anion and cation. What are the important points about covalent character? Covalent character, how is increases means, now covalent character. Now covalent character is decided by two factors. What are the factors? That is cation and anion. What ma? Cation and anion. Anion having polarizability. Next, cation having polarizing power. PP means polarizing power. What are the important point? Small size of cation, more polarizing power, more covalent character. Next one is more charge on cation, more polarizing power. Next one is the pseudo noble gas configuration. Having cations are more polarizing power, more covalent character. Here I am writing polarizing power means polarizing power increases, covalent character increases. Now covalent character increases means solubility decreases. Next one is the boiling point and melting point also decreases. And next one is the color imparting nature increases. That it is given color imparting nature increases. These are the important points about cation. Pseudo noble gas configuration means if you take a copper plus, silver plus and Rm plus. And polarizability means, what are the polarizability? And a larger size of anion. Anion size is larger. Next one is a more charge on anion. These also responsible for more polarizability, more covalent character. Now I am taking one example. If you take FeOH3 taken thrice and FeOH2, which one is more covalent character? For example, I am taking here is Fe plus 3 and here is Fe plus 2. Which one is the more charge? Fe plus 3 is the more charge. That's why more covalent character is increases, Fe plus 3. If you take MgCl2, CaCl2 and CaBr2, which one is a more solubility? Solubility means here is calcium plus 2 and bromine. Bromine means more charge on the, here is calcium plus 2, here also calcium plus 2, cations are same. Here is minus charge and here is minus charge, charges are so same. but sizes, chlorine and bromine, which one is a more size? Bigger size of anion. Bigger size of anion means covalent character increases. Based on Fazan's, what explained the Fazan's percentage of covalent character in ionic compound? This is the Fazan's rule. This is the very important. While you are any NEET exam, they are asking which one is the more covalent character. Means you have to give the answer by using these important points, cation and anion. And next one is the valence bond theory. Valence bond theory. What is valence bond theory? Is explained. Atomic orbitals are combined. Atomic orbitals overlapping to form covalent bond. How to form covalent bond? Atomic orbitals are overlapping. Who are overlapping? Atomic orbitals are overlapping to form covalent bond. This is proposed by Pauling and Slater. These two scientists, before also some scientists are, some fellows are explained, but Pauling and Slater is the suitable explanation of valence bond theory. And next one is the atomic orbitals of same energy, nearly same energy, or nearly same energy orbitals are overlapping. Overlapping must be, what is the overlapping? Overlapping orbitals having electrons are opposite spin. For example, this one is a s orbital. One s orbital is this one, and another one s orbital is overlapping, means this one. Overlapping orbitals having electrons are opposite spin. They are involved in overlapping to form. Next, overlapping must be less than 50%. What are the important points of valence bond theory? Atomic orbitals are overlapping to form covalent bond. Next one is Pauling and Slater is proposed this valence bond theory. Atomic orbitals of same energy, nearly same energy orbitals are overlapping. Overlapping orbitals are having electrons are opposite spin. These are the orbitals, electrons are opposite spin. Next one is the overlapping must be less than 50%. These are the important points of valence bond theory. Another important point is, if extent of overlapping, more extent of overlapping means the strength of bond is increases. Now I am writing extent of overlapping increases. Then the more extent of overlapping means bond strength. BS means bond strength increases. Now bond strength increases means bond energy increases. Now bond energy increases means bond length is decreases. Extent of overlapping is directly proportional to bond strength, directly proportional to bond energy, inversely proportional to bond length. This is the order, remember. If extent of, there are the overlapping orbitals are, if it is having same sign, the overlapping orbitals are same sign, plus, minus, minus, plus, plus, minus. The orbitals are same sign means, for example, this one is a p orbital I am taking, plus, here is minus, here also, here is plus, here also minus. This one is same side overlapping, means involving orbitals are having same sign, that orbitals are involved in covalent bond formation. Now there are two types of bonding. One is sigma bonding, sigma bond. There are two types of bonding. One is sigma bond, another one is the pi bond. How to form sigma bond? S orbital and s orbital to form sigma bond, and s orbital, p orbital, and p orbital to form sigma bond. Here is p orbital mixing, and p orbital d orbital mixing, d orbital mixing to form pi bond. But sigma bond is the more extent of overlapping. That's why sigma bond is the more stronger bond, and pi bond is the weaker bond. In pi bond means what type? There is lateral overlapping, and sidewise, lateral and sidewise overlapping to form pi bond. Here is axial overlapping or head to head overlapping to form sigma bond. Now we can take one example, sigma bond SS orbital, SP and PP. Here is PP orbital, PD orbital and DD orbitals. Now SS mixing to form S orbital I am taking SS mixing, S orbital. Here I am taking S orbital, one S orbital, another S orbital, they are that is overlapping. We can term use is overlapping. In hybridization we use intermixing. Here is overlapping, SS, and we can take SP. One of the S orbital, another one is the P orbital. This one is a plus and minus. We can use this one. This one is the SP mixing. This one is the SS mixing. And next one is the PP mixing. Actually PP mixing, PX mixing, PY mixing, PZ. Because orientation of orbitals are different. That's why PP mixing. We can take P orbital, PX orbital I am taking. Here also PX and plus here also bonding. If you take this one plus means bonding. Plus minus means node is formed. Here also PX, it is formed like this. Minus and plus. This is called PP mixing. This one is the PP mixing. Which type of bond is formed? Sigma bond is formed. Next one is the P orbital, Py and Py orbitals are mixing. Py orbital means this is the plus and this is minus, and this is the plus and this is the minus. They are overlapping each other. Here is plus and minus. Because we can denote it like this. This is the Py mixing means to form pi bond. Pi bond is formed. If you take next one is the P pi. If you take this is the P orbital minus. If you take D orbital I am writing. Here also there is mixing. This is called P pi D pi bonding. This one is a P orbital means mixing means P pi. Here is P pi D pi. If you take another one, d pi, if you take this structure d orbitals, and d orbitals are mixing, that is the d pi bonding is present. D pi bonding is present. This is the sigma bond and pi bond. Next one is what is the difference between sigma bond and pi bond? The important points about sigma and pi bond. Sigma bond I am taking sigma bond, and next one is a pi bond. What is a pi bond? How to form sigma bond? Sigma bond is formed due to axial overlapping or head to head overlapping to form sigma bond. Sigma bond is the stronger bond. Pi bond is the weaker bond. Next one is pi bond is formed lateral overlapping or sidewise overlapping to form pi bond. Now coming to this is which type of bond? This is a stronger bond. Why it is stronger bond? Here is maximum extent of overlapping. Here this one is the weaker bond. This is the pi bond is the weaker bond. What are the mixing here? SS mixing, SP mixing and PP mixing to form sigma bond. Here is PP mixing, P pi, we can write PP orbital, P pi, D pi, and next one is D pi. These are the pi bond formation is formed. Here is extent of overlapping, because head to head overlapping means maximum extent of overlapping. Extent of overlapping is more. Extent of overlapping is more, means the bond strength, what happened? Bond strength increases, and now bond energy also increases. Even bond order, you know, number of bonds, bond order also directly proportional to, we can take bond order also inversely proportional to bond energy. Bond length. Bond strength increases means bond energy increases. Bond energy increases means bond order increases. Next, this one is bond order. For example, oxygen, double bond is present. Nitrogen, triple bond is present. And fluorine, single bond is present. Which one is the more bond order? What is bond order? Number of bonds between two atoms. Here is this one is the more bond order. Now, next one, here is the extent of overlapping is less. Extent of overlapping less, because sidewise overlapping means very less, only less overlapping. That's why weaker bond. Another point we have to write, and sigma bond is formed alone. Right? Sigma bond formed alone in between two atoms. For example, A and B. This is one sigma bond. Now I am taking pi bond, but pi bond is formed after sigma bond. Pi bond is formed after sigma bond. Next one. After sigma bond means, for example, I am taking in A and B. Now I am taking this one. One sigma bond, one pi bond. But it is not formed alone. Sigma bond rotation is possible. Sigma, CC sigma. But pi bond rotation restricted. Rotation is restricted. It is restricted. These are the difference between pi bond and sigma bond. I am taking example one by one. Sigma bond and pi bond. How many sigma bonds, how many pi bonds are present? Right, one by one, sigma bond and pi bond. Okay. Next one, I am taking water molecule. Here I am taking water molecule. Here is two lone pairs are present. How many sigma bonds? This is one sigma, one sigma. If I taking acetylene, C triple bond C H, how many sigma? This is 1 sigma, 1 sigma, 1 sigma. 3 sigma bonds, how many? 2 pi bonds are present. 2 pi bonds are present. I am taking HF. For example, I am taking HF. Which type of bonding is present? Means SS mixing or PP mixing. Here is s orbital. One of the, what is the electronic configuration of hydrogen? 1s1, 1 hydrogen. Okay, now fluorine I am taking. Here is fluorine 1s2, 2s2 and 2p5 pi. I am writing 1s2 here 2 and 2s2 here also 2. 2p pi means 1, 2, 3, 4, 5. Now this of the s orbital of hydrogen and pz orbital of px, py, px, py, pz. Pz of, here is what is mixing? S and P mixing. Here is S and P mixing. If I am taking BF3, BF3 I am taking boron, boron trifluoride. Trifluoride means boron, what is the electronic configuration? Boron is 1s2, 2s2 and 2p1. 2s2, 2p1. Here I am taking fluorine. Fluorine 3 fluorines I am taking. That is a last 1s2, 2s2, 2p5. 2p5. Last orbital I am writing p orbital. The 3 p orbitals are present now. Another p orbitals also present. Here is 1, 2, 3, 4. 2p5. Here is 1 electron. 1, 2, 3. Here also 4, 5. 2p5. Fluorine. 7 electrons now. 1s2, 2s2, 5, 2, 7, 8, 9. Fluorine atomic number is 9. 1, 2. Next one is I am taking here. Here also completed now. Now this one, if you take this one means a final 5 orbital. Okay, here is 1, 2, 3, 4, 5. 1, here is Z orbital, P Z orbital. This is Px, and now I am taking Py is alone. Py is alone. Now here I am taking boron. Boron is ground state. Ground state. One of the electron jumping to the s orbital to p orbital. Now 2s and 2p orbitals means this 3. Now one of the electron, this is the first excited state. First excited state, one of the electron jumping from s orbital to p orbital. Now how many ss mixing? This one s orbital s, this one p and p, and this one p and p. What is the mixing? This one sp mixing, pp mixing, and here also pp. Which type of orbitals? 2s and 2p, and 2p and 2p mixing, and here 2p and 2p, and here 2s and 2p. This type of interactions are present according to the valence bond theory. According to the valence bond theory. If you take nitrogen and oxygen, which type of bonding is present? Nitrogen and oxygen. I am taking nitrogen. Just nitrogen I am taking. Nitrogen means N triple bond N. Now I am taking 1 nitrogen. What is the electronic configuration? 1s2, 2s2, 2p3. Here also I am taking 1 nitrogen. 1s2, 2s2 and 2p3. Okay. Now here 3 p orbitals are present. Here also how many 3 p orbitals? It is subshells. If you take 1, 2, 3. Here also 1, 2, 3. Nitrogen and nitrogen. Here is px, py and pz. Here also px, py and pz. Here now I am taking nitrogen. Here also 1 nitrogen. Px of nitrogen, 1 nitrogen, px of nitrogen. There is sigma bond is formed, and p orbital of pz. This one is the py and pz. Here is a pz orbitals. Here is overlapping between which orbitals, and this one overlapping, this one overlapping, and here which overlapping, this one overlapping, this one, this is the pi bond, this is the pi bond, one is the sigma bond. This one px overlapping, py overlapping, pz overlapping. This is the nitrogen. How many bonds are present between nitrogen? 3 bonds are present. One is the sigma bond, 2 pi bonds are present. This is the valence bond theory. According to valence bond theory, we can easily write the number of bonds between sigma bonds easily. We can write, and pi bonds easily. We can write it. Next class, we will explain hybridization and dipole moment and VSEPR theory. From chemical bonding, 3 to 4 questions are asking every time, and who are preparing NEET exam, please concentrate chemical bonding, biomolecules and GOC and environmental chemistry and like that biomolecules. These are the scoring chapters, and all the best to your preparation. Okay.